Hello students, welcome to another wonderful addition to our class's YouTube channel. Remember, if you want access to this video or any of the other videos that I've made, all you have to do is go to YouTube and subscribe to my YouTube channel. You just type in Eric Austin in the search bar and I should be the first Eric Austin that pops up. All you have to do is hit subscribe. That way you'll have instant access to all of my videos, either on your personal computer, your tablet, or your smartphone. All right, let's go ahead and jump into today's lesson. Today we're going to be going back and reviewing rational and irrational numbers, and specifically we're going to be focusing on how do we get an approximation or an estimate for irrational numbers. All right, don't forget
to follow along on your guided note sheet. That way you'll have something to refer back to as you review for tomorrow's test. All right, first thing. Rational numbers have what we call terminating or ending or repeating decimals. So that means when we write a rational number as a decimal, it will have a terminating decimal, or the decimals will not go on and on in random forever. If they do go on forever, their decimal will repeat itself. Alright? So those are the two ways you can tell a rational number apart from an irrational number. If it has a terminating decimal or if it has a repeating decimal, those are rational numbers. So let's look at a couple of examples, and these examples go into these first four boxes. Alright, the first example, 4.2, and it has a terminating decimal, so that would be a rational number. The fractions can also be rational number. If we look at the fraction 3/4, if I turn that into a decimal by dividing 3 by 4, I would get 75 hundredths, and it terminates, so it'll be a rational number. My third one is an example of a repeating number, or a repeating decimal that goes on and on forever, but it has a pattern, or it repeats in a certain order. So if I look at 1/3, if I was to divide 1 by 3, I would get 3/10 repeating, which means this 3 would go on and on forever. Since even though it goes on and on forever and it doesn't have and it doesn't terminate, we still consider this a rational number because it does repeat. So remember, terminating decimals like here are rational numbers, and so are repeating decimals. Those are rational numbers as well. Alright, another example, sometimes you won't just have one digit repeating, sometimes you'll have a group or multiple digits repeating. Like in this example, I have the digits 3, 8 repeating on and on forever. That dot, dot, dot lets me know that it goes on forever. But notice it does have a pattern. It's 3, 8, 3, 8, 3, 8. So I would call that 38 hundredths repeating. So this little bar over my 3 and 8 tells me that those two digits go on and on forever. Just like here with my 3, that little bar meant that 3 went on and on forever. So all four of these are examples of rational numbers we see all the time. Now let's take a look at irrational numbers. Alright. Irrational numbers obviously are the opposite of rational numbers. So irrational numbers have non-terminating decimals. So their decimals go on and on forever. And non-repeating decimals. So not only do those decimals go on and on forever, but they also don't repeat each other in a certain order, like we saw with rational numbers. Alright? And for that reason, we can never get an exact value for an irrational number. We can only get an approximation or a close estimate to what the value of an irrational number is. Alright, so some examples of some irrational numbers we see in the mathematical world. One would be the number pi. Alright, we use pi a lot in math, and normally we consider pi, we just use the approximation or the estimate 3.14, but it's important for you to understand that that decimal repeats on forever. So really when we estimate pi as 3.14, it's really just an estimate of what pi is. That is not the exact value for pi. So it is an irrational number. Alright, a couple of other irrational numbers you'll see in 8th grade and moving on through your educational career are imperfect squares, like the square root of 27. 27 is not a perfect square. So if we were to take the square root of it, we would get an irrational number, or a non-terminating decimal. This number goes on and on forever. So the square root of 27 is approximately, or estimated to be about 5.196, and those digits keep on going. So that's a close estimate to what we can get for the square root of 27. Same thing with the square root of 10. It is 3.16, but those digits go on forever in a non-repeating fashion. So those don't repeat each other, they just go in a random order. So those would be irrational. This would be an irrational number. Another way to sum all of that up is just think of all non-perfect squares are irrational numbers. So if it's not a perfect square and we try to get the square root of a non-perfect square, it's going to be irrational. Alright.
Example 1. Example 1, if you're following along on your note sheet, your guided note sheet, asks us what is the approximate value of the square root of 75 to the nearest, and this is important, hundredth place. So we need to get a close estimate to the hundredths place. So that's 2 places behind the decimal point. All right, step one, and I don't want you to go ahead and copy this down. So stop, I want you to listen first, and we'll pause the video after we get done with this board so you can jot this down. So for the first part, just listen to it. Step one, find the lower perfect square and the upper perfect square in relationship to the one we're looking for, so the square root of 75. So what I did was I just listed out all of my perfect squares. All right, so the way you get your perfect squares, remember, we just square the number. So I start with 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. I skipped 16, sorry about that, but 4 times 4 is 16. It should go here. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And I can stop right there because 75 falls between 64 and 81. So I can stop once I get those perfect squares. So if you ever forget where the number falls, just start with 1 and list out all of your perfect squares. Or start with one you know and go from there. So the square root of 64 is 8, and the square root of 81 is 9. So I know that the square root of 75 is between 8 and 9. So I can say it's 8 point something. Now what we're about to focus on is how do we get this something? All right. So we have to follow through steps 2 through 4. Helps us get this decimal point, and it's really important that you know how to get that decimal. So the first thing we're going to do is we're going to subtract the square root we're looking for, so 75, we're looking for the square root of 75, from our lower square, which was 64. So 75 subtract 64, we get 11, and we're going to mark that as our numerator. This 11 is our numerator. Next, we're going to subtract the lower square from the upper square. So I have 81 as our upper square, upper perfect square, and I subtract 64. All right, and then I get 17, and I'm gonna label that my denominator. So basically, you take your lower perfect square and you subtract it from both the number you're looking for, the number in the question, and the upper square. All right, you always subtract the lower square's value. All right, so once you get your numerator and denominator, all you have to do is turn it into a fraction by using division. So I just divide 11 divided by 17, and here I showed my work here. I put 11 inside of the division house, 17 goes outside of the division house. All right, I add my decimal 0, and then I just divide like normal. So 117 or 17 goes into 110 6 times. I'll multiply, get 102, and then I continue my division steps. Now I stop once I get to this thousandths place, because in my question it said I had to give it an approximation to the hundredths place. So here I take that 7. This 7, remember, if it's more than 5, we round up. If it's 4 or less, we stay where we are. Since that is a 7, it's above 5, I'm gonna round this 4 to a 5 to get 0.65, and that's where I get that decimal. All right. So you might want to, when you get home, you might want to look at this video again so you can go over those steps. We went over it before, but sometimes we get a little confused on how do we get these decimal points, and you won't be able to use a calculator on your test tomorrow. So you want to be able to get those decimal points without a calculator. All right. You may have to plot that number on a number line, and just wanted to review that 8.65, if I plotted that on a number line, I have the number 8 here, and then on this number line it goes in tenths, so 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, and 8.65 is going to be between 8.6 and 8.7, so it's right there. So the square root of 75 falls right here on the number line. And remember, the number 9 is way over here. All right, so it does fall between 8 and 9, but it's closer to 9 than it is to 8. All right, very important. This is a very important board that you want to make sure you understand before tomorrow's test. All right, I'll go through one more example.
Looking at example 2. On example 2, I just basically just did the steps. I didn't make you do too much writing. I took 52, and this time I didn't list out all of my perfect squares because in my mind I know 12 times 12 is 144. That's really close to 152. So 12 times 12 and then 13 times 13 is 169. So my two perfect squares, I have my lower square here and my upper square here, my upper perfect square. And so I know that the square root of 152 falls between 12 and 13, so it's 12 point something. And remember, to get this something, we have to do some extra steps. So I took 152, the number I'm looking for. I took 169, my upper square, and then I just subtract. So I subtracted my lower perfect square, 144. Alright? And so when I do that, this is my numerator 8. 25 is my denominator. And then I can just divide from there. So 8 divided by 25, I would get 0.32 or 32 hundredths. And if I wanted to round it to the nearest tenths place, I go to my hundredths place. Since that's lower than 5, I can leave this 3 alone. So I would give an estimate of 12.3 for the square root of 152. Alright, and to plot that on the number line, it'll fall somewhere really close to 12, because 0.3 or 3 tenths over 12 is not that much, so it's right here on our number line. Alright, make sure you get this, do the independent practice problems, and I'll see y'all in the classroom tomorrow. Peace out.